Yes, welcome back. I think my camcorders may be broken. This one, it will not start. It's a black screen. Something wrong. Let's look at that later. Let's try to, but this camcorder is old too. So just use this old pocket camcorder. It's not so good like the other one, but that's what I got left. That's this old pocket camcorder. But the next PDF is a kind of long, so we need to get started. I have to look this camcorder later. The sun is still shining. But now we have to turn. I can turn my. I can read like this because. I can put this camcorder on this can of tomatoes. So I like to keep the video one part, but now this video splits in 15 minutes. Now I have 5 minutes less and 2 minutes now, so let's get started.
Rolladen-Schneider LS8. LS8 roll standard class and 18 meter class sailplane national origin Gemini manufacturer Rolladen-Schneider. Flugs for first flight 1994 number build 491. The Rolladen-Schneider LS8 is a standard and 18-meter class single-seat glider developed by Rolladen-Schneider and in series production since 1995. Currently it is manufactured by DG Flugsbau. Development. By the mid to late 80s the LS4 had lost its leading position in the standard class to new arrivals, in particular the excellent discus from Skemperth. The LS7, in spite of its advanced design, did not recapture the lead and, with flagging sails, Rolladen-Schneider went back to the drawing board. Designer Wolf Lemke was skeptical of the usefulness of developing a new airfoil. There was no guarantee that the large effort and investment required would bring any palpable gains, as the LS7, ASW24 and DG600 had clearly shown. The tools available at the time were simply not up to the task of reliably predicting the performance in everyday conditions of the new laminar flow profiles then emerging from the research labs. The 15-meter class LS6, which first flew in 1983, was however achieving surprisingly good results flying with locked flaps in the non-FAI sanctioned sports class in the United States. Following this lead, Rolladen-Schneider modified an LS6C by removing the flap handle, resetting the wing at a slightly higher angle of incidence and adding winglets. This experimental prototype outperformed state-of-the-art standard class sailplanes both in side-by-side flight tests and in contests including the German championships at Neustadt Blue. The LS8 that finally emerged in 1994 had a few improvements over the prototype, the most significant being the redesigned ailerons and the lighter and aerodynamically cleaner wing made possible by deleting the flap system. Examples of the LS8 scored second, fourth and fifth in the 1995 World Gliding Championships. At Omarama, New Zealand, first, second and third in the 1997 World Gliding Championships at Saint-Ouen, France. 6 out of the first 10 positions in the 1999 World Gliding Championships in Bayreuth, Germany. The first 3 places in the 2001 Women's World Gliding Championships in Lithuania and, more recently first, and 9 out of the first 10 places, in the 2005 Women's World Gliding Championships in Plix, Germany. In 2006 World Gliding Championships at Eskilstuna, Sweden, LS8 took the first and third places. LS8 was the winner of 2002, 2004, 2005, and 2007 European Gliding Championship. Many regard it as the best all-round standard class glider. Commercially, the LS8 was very successful, due to its competition potential and to the gentle and easy fly characteristics that make it suitable for club and leisure flying. Primarily to cater to the latter market, versions with longer wings and a turbo or sustainer version were developed. A total of 491 examples of all subtypes had been manufactured by December 2005. Despite the commercial success of the LS8, the company producing it failed to prosper, and after a slightly acrimonious court battle, the LS8 and other Rolladen-Schneider aircraft passed to DG Flugsbau, where it is still currently in series production. The LS8 manufactured by DG has some alterations to the main wheel, the turbo version, etc., and slightly different model designations from the original's. Turbo development. The development of the sustainer turbo version went through several iterations, with the original prototype being manufactured by Rolladen-Schneider for Peter Wright, who designed a unique turbo design where the engine remained in the engine bay and drove the propeller via a belt. Peter had many years' experience working in composites, design and the Formula One industry. The prop, which extended rapidly through a pneumatic mechanism, was belt-driven via a belt that ran inside the pylons, which were carbon fiber aerofoil sections to minimize drag. The engine could be started using a starter motor before deploying the prop with the engine already running. A small alternator then recharged the battery and pneumatic as well. Air inlet and exhaust were accomplished through small pneumatic doors at the bottom of the fuselage, again to allow engine running with the prop /pylons still in the bay and the main fuselage doors still closed. This arrangement, whilst being greatly admired by many, was determined by the manufacturer to be too complex and expensive, and a much more conventional turbo design was eventually selected for production by Rolladen-Schneider. The LS design has since been modified by DG after their acquisition of Rolladen-Schneider, with DG's in-house DEINT engine control system. The original prototype LS8T turbo was, after difficulties with new ESA regulations trying to export the aircraft to France, converted back to a more or less standard LS8B, where it remains on the British BGA register, now redesignated as LS8PW, so named after Peter Wright, who designed and built the engine installation, with the competition number F1. It is still unique in being the only LS8 currently on the CAA-ESA Annex II list due to its status as a prototype, mainly due to the use of unidirectional carbon fiber on the wing skins, an attempt by Rolladen-Schneider to improve the surface finish. Production turbos returned to using woven carbon again because of the increased production costs associated with using the more difficult to cut and handle unidirectional material. 1. Design. The LS8 is a flexible and relatively conservative design with high development potential. Although primarily designed to standard class specifications, it has lent itself easily to span extensions, motorization, etc. Aerodynamic configurations. Winglets are default for all spans. Wingtips extending the span to 18 meters are an option available to some versions. Structure. Wings, winglets, ailerons and horizontal stabilizer are carbon forward/foam sandwiches. The elevator has a mixed carbon forward/pyramid construction. The longer span versions have a stronger main spar. The cockpit is a double fiberglass shell for increased crashworthiness. Control system, conventional, split elevator forward/horizontal stabilizer for longitudinal control and subsurface skimp earth air brakes for glide path control, ailerons with marked differential occupying the outer 50% of the wing's trailing edge. Controls via pushroots with automatic coupling during rigging. Mass balancing. The aileron control system is mass balanced, with integral counterweights inside the wings. The ailerons themselves are also mass balanced in the longer span versions, with up to 1.5 kilograms of lead added to the leading edges of each control surface. The elevator and rudder are 100% mass balanced. Sealing. All control gaps as well as the control runs inside the wings are fully sealed. The ailerons are sealed by internal Teflon boots. The resultant very low friction ensures exceptionally light stick forces. The horizontal stabilizer and rudder retained Teflon and mylar strip seals. Ballast system. Integral ballast tanks with 2 tanks per wing in the LS8 and subsequent versions. A smaller tank in the tail fin, with a capacity between 3.5 and 12 liters according to version and options, allows center of gravity corrections. Wheel brake, operated by pressing on the rudder pedals. In DG build versions also coupled to the air brake lever. Turbo. The Sola 2325 engine is mated to a small diameter paddle propeller that sacrifices a small amount of propulsive efficiency in exchange for much smaller drag if the engine fails to start. The hydraulic extender allows instantaneous extension. DG build sustainers have conventional electricity-driven spindle extension. Variants. Rolladen-Schneider LS8, original version with LS6C style ballast bags, removable fin tank and span limited to 15 meters, 6 built. LS8A, version with stronger spars and integral water tanks allowing conversion into an LS8-18, 438 built, together with LS8-18. LS8-18, as LS8 plus mass balanced ailerons and an integral tail tank. Can be operated in 15M and 18M mode, 438 built, together with LS8A. LS8B, as LS8-18. Structurally prepared, wings and fuselage, for retrofit of a self-sustainer engine, 36 built, together with LS8T. LS8T, B with self-sustainer, turbo, 36 built, together with LS8B. DG Flugsbau. Following the transfer of ownership, subtype designations and specifications changed slightly. LS8A, as the previous model except the spar is not reinforced for span extension. LS8S, corresponds to the previous LS8-18 model, with a larger main undercarriage, viewing further reinforced for an increased maximum weight of 575 kilograms in the 18M mode and of the minor changes. 11 built, together with LS8ST. LS8ST, self-sustainer version, differs from the previous LS8T in the same ways as the LS8S. Additionally, an electrically driven spindle and a DEINT engine control unit supersede Rolladen-Schneider's hydraulic engine extraction system and the original Walter binder controller. 11 built, together with LS8S. LS8 Neo with a front electric sustainer. Version-specific characteristics LS8, LS8A, LS8-18, LS8B, LS8T, LS8S, LS8SD wingspan. M1515/18 tail water ballast, L3.8/5.5127.5 empty weight, kilogram 24024525028 typical empty weight in service kilogram 252267275 maximum takeoff weight. Kilogram 525/575/575 maximum wing loading, kilogram /M25050/4650/50.4 engine type Solo 2325 Solo 2325 engine power, HPCA 23 CA 23 fuel tank volume, L17.3-17.3 Specifications, LS8-18 with 15-meter wings. General characteristics crew, 1 pilot. Capacity, 202 kilograms, 414 pound, water ballast. Length, 6.72 m, 22 feet 1 in. Wingspan, 15.00 m, 49 feet